And so we're going to start chapter 8 today, and that is about gravitational forces and central forces. What are central forces?
Forces that come from the center.
Forces that are only a function of r. No thetas, no phi's, no l's, no x's, nothing. It's just forces that move in a circle, and they are only a function of r. Gravitational forces are forces between masses. Forces between masses. And Newton's law of gravitation says F between 1 and 2 equals G m1 m2 over r squared, where r is the radius between the two objects. When objects are very, very large, we start from the center of one object to the center of the other object. And we have a unit vector that points in the right direction. This is mass 1, this is mass 2, that is r between the two masses. The forces exerted by both masses is equal, and it acts towards the other one. We can also calculate the potential energies between them. Oh, and this is called what? We can also calculate the potential energies. What do we know? We know F equals minus partial U over partial X. So in this case, it will be partial U. Since it is only a function of r, may I replace this by minus du over dr? The partials go away and you get full. If this was written as a vector, would Newton's law be written as F equals minus G m1 m2 over r squared, vector form? The minus sign shows attraction between the two objects. So if I was to calculate the potential energy, how would I do this? F dot dr equals du with a minus sign, which means I can write minus G m1 m2 1 over r squared dr equals minus du. Minus signs go away, and I can integrate both sides from some infinity to some r. What is the integration of 1 over r? Let me do it here. Integration of 1 over r squared to dr is r minus 2 plus 1 divided by minus 2 plus 1, or 1 over r. And 1 over infinite is 0. So may I write this as G m1 m2 minus 1 over r equals u at r. What is the potential at infinity? Nope, and at infinity potential is 0, right? So you get u of r. Okay, so this means I can rewrite this as minus G m1 m2 over r equals u. So this is the potential energy of a particle. Sometimes books write a term called big phi, and that they define as gravitational potential energy divided by mass. And this will be written as Gm over r, especially in situations where one mass is quite a bit bigger than the other one. Instead of talking about potentials, they talk about this term, which is called the gravitational potential. Gravitational potential. So if you ever see a term written divided by m or the mass, know that they're talking about gravitational potential. They do the same for forces, where they will write, instead of force, they will write this fancy looking G. Okay, I can't draw that G, but it's gonna be like a really fancy looking G. And they define this fancy looking G as F over M. And this is called minus G M over R squared. And they call this the gravitational field intensity. I just want you to be aware of them, of books doing that. We won't necessarily deal with this, just so you know. But if ever you see it, that's what it means.